Very good evening to dear students. Today we are here to write the IUPAC nomenclature of the bridging ligands, the coordination compounds. So the bridging ligands are the one which are the ligands which join two metals together are known as the bridging ligands. So bridging ligands can be of multiple types. I'll be dealing with all of them. Here the very first ligands are of two types. Now you can see here this OH ligand is joining, this is joining two groups. Now ligand can be represented as L, and since these two groups are different, they can be represented as X and as Y. So the general name of these reactions of such types of compounds is written as, general method to write that. First of all, we will write down the name of the X, whatever is X, we will write it down, name of X, and we will write down we use mu as a prefix for writing down the name of the ligand that is acting as a bridge, and then we will write down the name of Y. So doing some questions, the name of this complex is, the very first thing we will write down the name is, this is 4 water molecules, so we have written the name tetra aqua nickel, and then mu hydroxo. This mu is used from here for the bridging ligands, mu hydroxo, and then we have got again tetra aqua cobalt chloride. Now for solving the oxidation number of the same, we can use the methodology. We can use the oxidation number, since water, for water we can take as 0, for nickel we can take as X, for OH we can take as -1, for cobalt we can take as X, for water we can take as 0, and for chlorine we can take -3 is equal to 0. So 2X is equal to 4. So X comes out to be 2. So we have used these two symbols, 2 and 2 here. I think this is clear why, and this is used to represent the oxidation number. Next, we will solve some other questions of such things. So this is another compound, and it's here OH is acting as the bridge between these two ligands. Both these groups are different, and its name is, you can again see its name is pentaamine for 5 ammonia molecules, chromium. Mu is used for the bridging ligand, which is hydroxo here, and 5 penta aqua cobalt chloride. So again we have used the same methodology for finding out the oxidation number of the chromium and cobalt. I'll solve it again. It is, for ammonia we have taken X, we have taken 0, and for chromium 0, chromium X. For OH we have taken -1, for cobalt we have taken X, for water we have taken 0, for chlorine we have taken -5. This comes out to be 0. So 2X is equal to 6, and then finally X will be 3. So we have used 3 here and 3 here as the oxidation number of both the transition metals involved in the formation of the complex. Next, moving on to next type of ligands. Here you can see this is a different type of ligand. In this one, different type of complex. In this one, this ligand is acting as a bridge between two different metals, but here these both groups are same. In this one, this type of complex is formed here, L, X and X. So their name, general naming is done using this formula. Mu, name of the ligand, is written first, and then bis is used since these two X molecules are same. So bis and then name of X. So I'll solve the very first question. In this one, we have used mu hydroxo. Mu hydroxo, name of the ligand is written first since hydroxo OH is the ligand here that is acting as a bridge. So its name is written as mu hydroxo, and these two groups are same. We will use bis for this one. Tetra aqua is written, and nickel is the central atom, chloride. So for solving out the oxidation number of the nickel, we will again use the same pattern. 0 is taken for water and nickel is taken as X. OH we will take it as -1, and again nickel is taken as X and water is taken 0. For chlorine we will take -3 is equal to 0. So 2X is equal to 4. So X is equal to 2. And this we have used in the parenthesis used in the nomenclature. Next, solving some similar questions. Now here, for writing the name of this complex compound, we have used mu hydroxo bis for 4 ammonia molecules, tetra aqua nickel chloride, and we have solved the oxidation number 2 using the same formula as we have used above. Next, now there are some complexes in which there are two ligands that are acting as a bridge between the central atoms. Now this is the general representation for these compounds, and these two are the ligands. These two are the ligands. They are written as L1 and L2 here. And for writing out the name of these two different groups, this group is written as X and this group is written as Y. So the general naming of these compounds is done. First, we will write down the name of the X, whatever is the X group. X group is here. And then we will denote the ligand, bridging ligand using mu, and name of the L1, mu, name of the L2. L1 and L2 are written here alphabetically, and then we will write down the name of the Y group. Solving this question, its name comes out to be tetraamine. We will write down the name of X group, tetraamine cobalt, mu amido for this one, mu hydroxo for this one, and then diamine dichlorido cobalt 3 sulfate. This one oxidation number is calculated as we have calculated earlier. We will take 0 for ammonia, X for cobalt, NH2 is taken as -1, OH is taken as -1, again cobalt is taken as X, ammonia is taken as 0, chlorine is taken as -2, and sulfate is taken as -2 is equal to 0. On solving this, 2x is equal to 6 and x comes out to be 3, which is written here in the square brackets. This is the written square 3. It is representing the, in the parenthesis, representing the oxidation state of the transition metals. Next, these are the questions. Now I'll solve these, try to explain these. Here name of X is written first. Name of X is written here, tetraamine cobalt, and name of the bridging ligand mu hydroxo, mu nitro, and then again writing the name of the Y. It is diaqua dichloro cobalt 2. Next is writing down the next bis. Bis is written here because in the name of the X there is already diethylene. So we have used bis here. Ethane 1,2 diamine, cobalt 3. Writing down the name of the bridging ligands, mu amido, mu hydroxo. Then again writing down the name of this complex, diamine, dihydroxo, cobalt 3 nitrate. And then for solving out the oxidation state, so ethylene diamine, we have got 0 charge on ethylene diamine. And then for cobalt, we have taken X. For this NH2, we have taken -1. For this OH, we have taken again -1. For this cobalt, we have taken X. For this ammonia, we have taken 0. For OH, we have taken -2 here, since 2 molecules. For nitrate, we have taken -2. So 2x is equal to 6 and x is equal to 3. And the same is denoted in the parenthesis while writing down the name of these compounds. Next, the other type of complex that we could see in the coordination compounds is such type of compound. And here we can see that, the compound is named here. We have got ligand 1, and ligand 2. They are represented as L1 and L2. But the important point to see here is that these two groups are same. So we have written as them X and X. So in such cases, the name of the ligands is written first as according name of the ligand L1, alphabetical order, and mu name of the ligand L2. And then we'll use bis, since these two groups X, and are same, and then we'll write the name of the X compound. Writing down the name of this complex compound is, you can see clearly here, it is the mu amido alphabetical order, writing the bridging ligand mu hydroxo, bis tetraamine cobalt 2 nitrate. 2 oxidation state is found out using the oxidation number method. And the next question that these are the 2 questions, we'll solve it and we'll discuss it. Now, writing down the name of this ligand is mu amido is written at first, and mu nitro, bis. Again here we have got bis here, and it comes out to be ethane 1,2 diamine cobalt sulfate, and finding the oxidation state using the oxidation number method. Now solving this question, it is the name of the bridging ligands mu amido and mu hydroxo is written first. We'll use bis since both groups are same. It is tetraamine iron 2 chloride. I think it's clear to everyone. Next, we will come across some compounds. Here in these compounds, these ligands are same, and these two groups are also the same. So ligands are represented as L1, L1, and groups are represented as X and X. In this case, we will use the prefix di. We will use the prefix di before the name of the ligands. Di, name of the ligand, then bis, and the name of the X. This is the general nomenclature, general name for this reaction. Di is used since both bridging ligands are the same. Mu hydroxo, bis is used, and then tetra aqua iron 3 sulfate. So for finding out the oxidation state, once again I'll try to solve it out. It will be, we will take 0 for water 0. For iron we will take X. For 2OH we will take -2. For iron again we will take X. For water we will take 0. And then for sulfate we will take -2, and there are 2 sulfates, so it will be -4 is equal to 0. So 2X is equal to +6. X is equal to +3, which is written in the parenthesis here. Next question, writing down its name. Its name is again very simple. Its name is di-mu-amido, amido for the bridging ligands, bis hexaamine cobalt chloride. And again, the oxidation state of the transition metal is found out using the oxidation number method. Again, solving another question, we have got you can see here now it is di-mu nitro and bis hexa aqua cobalt 2 nitrate. So these are the next. So these are the compounds of bridging ligands. So I'll once again deal with this. So different type of compounds that we will study during bridging ligands are the one will those will be having one ligand connected to 2 different type of groups. The other will be another type of compound that will come across is where a ligand is connected to same type of groups. These groups are same, and their general name is written as name of the ligand is written first, followed by name of the groups. Another type that we studied today is there are 2 ligands. 2 ligands will be joining 2 ligands L1 and L2, and there will be 2 different groups. Groups are X and Y groups are different, and their general name is written as name of the X followed by name of the ligands and then followed by name of the Y. These were some examples. Now these are the another type of complexes. In this one, the ligands L1 and L2 are joining together the groups which are same, X group are same. So their name is written, name of the ligand L1 and L2 are written first, followed by the name of the group X. And these were some of the examples that we have done under these category. And the last category that we studied were where the ligands were same and the groups were also same. And these were written as general naming was done as di mu name of the ligand followed by bis as a prefix and name of the X. And these were some of the questions that we have done. And I hope you enjoyed this nomenclature, and all your questions related to the bridging ligands will be solved using this video. Thank you.